Good morning, student. Today we are going to discuss about the soldering of PCB. In the previous classes, we discussed about the PCB cleaning, etching, drilling, and so many things. After preparing all the things, we need to solder the components on the PCB. Soldering is very important in the PCB manufacturing. If we done proper soldering without having any faults, then only we can get the proper PCB. Today we are going to discuss about the designing of the designing of the PCB soldering. How we can solder a components on the printed circuit board, and what are the different types of soldering techniques are there. What are the basic principle we need to follow, basic steps we need to follow in order to solder the components. Now we try to discuss about these things. Soldering. Soldering is a process for the joining of metal parts with the aid of a molten metal, that is called as a solder. So what is the meaning of this soldering means? We are try to join the components or joining the metal parts with the another components by using the molten metal. Molten metal, the whenever the meaning is molten metals, we use extra thing. So by using that we try to connect these components perfectly. Soldering is a process for the joining of metal parts with the aid of a molten metal, that is called as a solder. Melting temperature is maintained below that of the material joined. The melting material, whatever we are using, the material should having the a low temperature melting point, and our component which we having the which we want to join, those components having the higher melting point compared to our melting material which we are using. The thing is, what we are doing in the main concept of soldering means we take the extra material, melting material, we try to melt that material by using the melted liquid. We join the components. Thereby surface of the parts are wetted without them becoming melted. Without them melted. The meaning is the surface of the parts, whatever the parts we want to join, those parts are wetted without them becoming the melted. Soldering is a process for the joining of metal parts with the aid of a molten material. A melting temperature is maintained below that of the material joined. Thereby surface of the parts are wetted without them becoming the melted. Solders have been in use since time immemorial. Solder was used in making jewelry, join the lead pipes for public baths. Today we can put most of the solder application into three major groups: mechanical joining, sealing, electrical conductive joining. So we having this in the far years, the thing is soldering is there, very common in the day-to-day life. The soldering have been in use since time immemorial. We can't know that one. From the beginning of the civilization we use this type of soldering. Solder was used in making jewelry, join the lead pipes for public baths. Today we can put most of the solder applications into three major groups. First one is the mechanical joining, second one is the sealing, third one is the electrically conductive joining. So these are the three different types of soldering techniques or soldering groups we have. Now the third group is used in the electronic application. So that is electrically conductive joining. Electrically conductive joining means the material which are used to join these leads or these components that should having the electrical conductivity. So that's why it is called as a electrical conductive joining. Electrical conductive joining. The third group is used in electronics applications. So that is our applications. Now we try to discuss different types of applications of soldiers. Different application of soldiers, you know that the jewelry making of jewelry. Next one is mechanical joints. You can see the diagram how we are joining. The third one is the electrical conductive joining, like this. You can see that is a PCB, and PCB we are connecting some leads by using a material which having the melting. After melting we make the surfaces are wetted, and after that we made dry, and it becoming a strong joint there. So this type of soldering we are used in the printed circuit board, that is electrical conductive joining. Electrical conductive joining. Principle of solder connections. Principle of solder connections. Soldering is a process for the joining of a metal parts. Soldering is a process for the joining of metal parts with the aid of a molten metal. With the aid of a molten or molten metal, that is a solder. That is called as a solder. The solder material is melting there. So using that, with the use of a molten metal, the melting temperature is situated below that of the material joined. What are the material we are joining? The melting temperature is below that of the material joined, thereby surface of the parts are wetted. Surface of the parts are wetted without them becoming melted. Without them becoming melted. Soft soldering or soldering generally implies that joining process occurs at a temperature below 450 degrees centigrade. We can say that our solder material having the temperature, melting temperature is 450 degrees centigrade. Soft soldering or soldering generally implies that joining process occurs at temperatures below 450 degrees centigrade. The filler metal, that is called as a solder. The filler metal or the solder wets and alloys with the base metals and gets drawn by capillary action into the gap between them. The meaning is, what are the solder material we are using? After applying this heat, that solder material becomes wetted and allies with the base metals and gets drawn by capillary action. Into the gap between them, the joinings. This process forms a metallurgical bond between the parts of the joining. So this type of wetting forms the metallurgical bond between the parts of the joint. Solder acts by what happening when the solder acts by wetting of the base metal surfaces. Wetting of the base metal surfaces forming the joint. First the material will be wetted. After wetting that, the material surfaces forms the joint flowing between these surfaces, which results in a completely filled space between them. Whenever it is wetted, that wetted material is flowing between these surfaces, and at last what it results is completely filled space between them. Metallurgical bonding to these surfaces when solidified. So what happens, then we can get the metallurgical bonding between these surfaces. Steps involved in soldering operation. Now we try to discuss about the what are the different steps involved in the soldering operation. Relative positioning of the surfaces to be joining, wetting of these surfaces with molten solder, allowing the solder to cool down until it has solidified, until it have solidified. That is the meaning. First what we need to do is relative positioning of the surfaces. What surfaces you want to join, those surfaces should be positioning relative positioning of these surfaces to be joining. What the surfaces you want join, all those should be placed relative positioning at particular point. After relatively positioning, then wetting of these surfaces with molten solder. By using the solder material molten solder, what we are doing is we are wetting them in order to join them. So wetting of these surfaces with molten solder. After solder, allowing the solder to cool down until it has solidified. Allowing the solder to cool down until it has solidified, as shown in the figure. We having the main thing is the heat, base metal, solder and flux we have. By using these three, we are joined by using the heat, base metal, solder, flux. So these are the three steps which are used in the soldering operation. So events during wetting of solder joint, you can see what happening whenever we want to join the two surfaces by using the solder. You can see in the diagram. The first we need to apply the heat. After we having the copper, this is a solid solder we want to add these two copper surfaces. So you can see the events during the wetting of the solder joints. You can see in the diagram. You can see the events during the wetting of a solder joint. Copper oxide, copper in compound, we have solder flux, you can see boiling flux, molten solder, plastic solder, you can see. So these are the different types of events occurs during the wetting of solder. We are having the solder material. If we apply the heat, the solder material may melted and it try to wet the surfaces of the joining copper. After melting it, whenever we are cooling that, it will be become as a solidified material. Contaminated surface soldering. If the surface of the material is contaminated, how it is you can see. Base metal we having a contaminated surface will prevent wetting. If the surface of the PCB is contaminated, it try to prevent the wetting of the material. So we try to see that there should not be any contaminant. Molten solder, you can see copper, you can see that a drop of molten solder on contaminated surfaces will behave like an isolated drop of mercury. You see, whenever we are melting this solder, if the surface of the joinings are contaminated, that molten solder is behaves as a drop of mercury, behaves as a drop of mercury. Can see, after solidifying, this drop can easily loosen when subjected to mechanical shocks. If that type of molten metal solidified, so this drop can easily loosen when subjected to mechanical shocks. So this is the thing. A contaminated surface soldering is, if you perform, the quality of the electrical contact in such case will be poor. In this type of contaminated surfaces, the quality of the electrical contact in such cases will be poor. The current has to pass through more or less insulating oxide film, more or less through the insulating oxide film. So this is the some of the disadvantages of the contaminated surfaces. What happens when we solder the contaminated surfaces? What happens whenever we solder a contaminated surface? A drop of molten solder on contaminated surfaces will behave like an isolated drop of mercury. After solidifying, this drop can easily loosen when subjected to mechanical shocks. The quality of the electrical contact in such case will be poor. The current has to pass through more or less insulating oxide film. Clean surface soldering. What happens when the surface is clean? You can see in the diagram, base metal properly wetted solder joint. The diagram shows that the surface is properly wet because of it is a clean diffusion layer, a molten solder. If the surfaces are clean, wetting takes place and solder will flow across the surface. Wetting takes place and solder will flow across the surface. The solder atoms are now able to come very close to the atoms of the base metal, hence they are attracted. The meaning is, now if the surface is clean, the solder atoms are now able to come very close to the atoms of the base metal, hence they are attracted. The solder thus gradually diffuses into the solid metal and provides a good adhesion. The solder thus gradually diffuses into the solid metal and provides a good adhesion. The direct metallic contact with the atoms of the base metal ensures a good electrical contact. This is the advantage of the clean surface. The thing is, whenever we are soldering, the surface of the joint should not be contaminated. If the surfaces are clean, what happens? If the surfaces are clean, wetting takes place and solder will flow across the surface. The solder atoms are now able to come very close to the atoms of the base metal. Hence, they are attracted. The solder thus gradually diffuses into the solid metal and provides a good adhesion. The direct metallic contact with the atoms of the base metal ensures a good electrical contact as shown in the figure. Next, after discussing about principle of solder joints, let us discuss about soldering alloys. Let us discuss about soldering alloys. What are the soldering alloys? Soldering alloys. Soldering alloys are special alloys which are used to get either mechanically strong joint or electrically joint with low contact resistance. The alloys also very important, meaning is in the electrical conductive joining. So we also have the joining resistance. This joining resistance also affect the functioning of the circuits. Soldering alloys are special alloys which are used to get either mechanically strong joint or electrical joint with low contact resistance. Soldiers have low melting points with the liquids temperatures below the melting point of pure lead. The meaning is whenever we use the alloys having the less melting point compared to the pure lead. The bulk of soldiers even melt below the 250 degrees centigrade. Some of the soldier alloys melt below the 250 degrees centigrade. So this is the advantage of the soldering alloys. These alloys provide the less melting point as well as less contact resistance. Soldiers have less tensile strength. Soldiers having the less tensile strength. We have types of alloys. Now we try to discuss what are the different types of alloys we are using. You can see the tin lead solder. Tin lead solder, that is the tin solder 63%, and the second one is the tin antimony solder, that is 95% tin and 5% in that 95% tin and 5% is the antimony. Third one is the tin lead silver solder, tin SN lead PB silver AG, that is 95% lead and 2% silver and 1% tin we have. In any solder system, lead is mainly used as a diluent only to lower the cost. Diluent which we are using the lead, the wetting phenomenon is dependent on the tin only. If the tin is more, the wetting is more. The wetting phenomenon is dependent on tin only. Next one is the higher the tin content, the better would be the wetting. The higher the tin content, the better would be the wetting. Types of alloys we having the tin lead solder, tin antimony solder, tin lead, silver, solder. These three are generally used alloys for the solder. So in any solder system we have the lead is the mainly used as a diluent. The wetting phenomena is depends on the tin. The higher the tin content, the better would be the wetting. Now we try to discuss about the other type of soldiers what we having. Tin lead solder. Tin lead solder. The binary matrix of tin and lead constitutes a simple and classical eutectic system with the eutectic point at 61.9 percentage tin and eutectic temperature at 183 degrees centigrade. So this is by using this binary matrix of tin and lead we need to seize these materials. You can see the diagram what is there. The metallurgical equilibrium diagram for tin and lead system. You can see at the point C. So that is the eutectic point. We having the point C in the graph is the eutectic point composition which vary from the eutectic one have rather a melting range than a melting or solidification point. The solder which correspond to the point D has a melting range of the 183 to 273 degrees centigrade and tin content of 30 percentage. So by using this type of binary matrix we select the our required proportion of the tin and lead. You can see the diagram. The point C in the graph is the eutectic point composition of which vary from the eutectic one have rather a melting range than a melting or solidification point. The solder which corresponds to the point D has a melting range of 183 to 273 degrees centigrade and tin content of 30 percentage. If a solder has a melting range, it is used only fully molten at highest temperature of this range. Cooling off must come down to the lowest temperature of the range for a complete solidification of the alloy. Cooling off must come down to the lowest temperature of the range for a complete solidification of the alloy. If a solder joint is disturbed during a solidification, it becomes unreliable. The meaning is during the process of solidification, the joint should not be disturbed. If the joints are disturbed during solidification, it becomes unreliable. The thing what is the function we want to achieve, we can't achieve that. Damages the joint. A solder with a narrow melting range for the soldering of electronic components chosen, since wide range solders increases the soldering time. So what we are using in the soldering of the electronic components is a solder with a narrow melting range. Narrow melting range for the soldering of the electronic components chosen, since wide range solders increases the soldering time. Wide range solders increases the soldering time. So that is the importance of this soldering, that is cooling off must come down. Cooling off must come down to the lowest temperature of the range for a complete solidification of the alloy. If a solder joint is disturbed during solidification, it becomes unreliable. A solder with a narrow melting range for the soldering of electronic components chosen, since wide range solders increases the soldering time. The characteristics of tin lead solder. So what are the characteristics of the tin lead solder? Now we try to discuss the physical characteristics. You can see specific gravity, kilogram per density meter cube, latent heat of melting, and specific heat, calories per degree centigrade, a final melting point degree centigrade, required energy from 20 degree centigrade, required energy from 20 degree centigrade. Specific gravity, you can see that is the, if it is 100% tin, we having the 7.3. If the tin is 63% and the lead is 37%, the specific gravity is 8.4. But if the tin is 37% and lead is 63%, the specific gravity is the 9.5. If without using the tin, if you only use the lead, we having the 11.4 percentage of specific gravity. Latent heat of melting, for the 100% tin, we having the 14 points are there, 63 and 73 we having the 13 is there melting point, and 37 tin and 63 lead we having the 10.5. If we use the 100% lead, we having the 5.5. Specific heat, you can see calories per degree centigrade 0.06 and 0.05, 0.04, 0.03. Final melting point, you can see for the 100% you need to have the 232, 63% and 37% we having the 183, 37 and 63 we having the 257. Only for the lead we having the 327. You can say that final melting point is good for 63% tin and 37% lead. Required energy from 20 degrees centigrade is 30, 24, 21, 17. Coming to the required energy from 20 degrees centigrade is we having other solder systems. You can see we having other solder systems are tin antimony. Tin and antimony also uses. We previously we used the tin and lead. We used tin and antimony. From the metallurgical equilibrium diagram for the binary tin antimony alloy system, it can be observed that only a composition with 5% antimony by weight forms a single phase solid solution in the tin. The tin lead antimony, we having the another one is tin lead antimony. For the most commonly used antimonial antimonial tin lead solder with a tin content of 30 to 50%, the liquid's temperature is slightly rise compared to binary system. The presence of antimony generally restrict the flow of solder. So this is the another type of solder systems, that is a tin lead antimony. For the most commonly used antimonial tin lead solder with a tin content of 30 to 50%. The liquid's temperature is slightly rise compared to binary system. The presence of tin or antimony generally restrict the flow of solder. The next one is the tin and silver. The eutectic point is reached with 3.5 percentage of silver, 96 percentage of antimony or lead giving an eutectic temperature of 220 degrees centigrade. The next one is the tin lead silver. Tin lead silver. Folder joints which must possess some strength at elevated temperature. An alloy of 97 percentage of lead, 2 percentage of silver, 1 percentage of tin is used. Tin is added because of the poor wetting qualities of lead. That's why we use the tin lead silver. 97 percentage of the lead, 2 percentage of the silver, 1 percentage of the tin. The next one is the tin zinc. These solders are specially used for soldering of aluminium. This type of alloys are used for soldering of aluminium. Tin zinc represents a simple eutectic system with the eutectic point at 8.9 percentage, zinc 91.1 percentage. Then tin resulting in a melting temperature of 198 degrees centigrade. The next one is the low melting point fusible alloys. The most commonly used alloys of this category is the ternary eutectic composition of 50% of tin, 32% of lead and 18% of cadmium, which melts a temperature of 145 degrees centigrade. So that's why it is called as a low melting point alloys. After discussing about the soldering alloys, let us discuss about the soldering fluxes. After discussing about soldering alloys, now we are going to discuss about the soldering fluxes. Soldering fluxes. Why we need these soldering fluxes? During the soldering operation, an auxiliary medium is mostly used to increase the flow properties of molten solder or to improve the degree of wetting. Such a medium is called flux. Why we are using flux means in order to improve the degree of wetting and also in order to increase the flowing property of molten solder. For this purpose we are using the soldering fluxes. Soldering fluxes during the soldering operation, an auxiliary medium. It is used mostly to increase the flow properties of molten solder or to improve the degree of wetting, such as a medium is called a flux. What are the characteristics of a flux? It should provide a liquid cover over the materials and exclude air up to the soldering temperature. The main characteristics is that it should provide a liquid cover, provides the liquid cover over the materials and exclude air up to the soldering temperature. It should dissolve any oxide, whatever the oxidate it have, it should dissolve any oxide on the metal surface or on the solder and carry such unwanted elements away. What are the unwanted metals are there? They may eliminate it. The meaning is it should dissolve any oxide on the metal surface or on the solder and carry such unwanted elements away. It should be readily displaced from the metal by the molten soldering operation. It should be readily displaced from the metal, readily displaced from the metal by the molten soldering operation. Residues should be removable after completion of the solder. Residues, whatever the remaining thing is there, should be removed after completion of the solder. It should reduce the surface tension of molten solder and spreads well. The meaning is it reduces the surface tension of molten solder and spreads the well in order to get the a good joint group of fluxes. So what are the groups of fluxes? We have the corrosive fluxes. One of the fluxes there, corrosive fluxes. The corrosive or acid fluxes consist mainly of inorganic acid and salts. The corrosive or acid fluxes consist mainly of inorganic acids and salts. They are used to solder difficult materials. These corrosive fluxes are used to solder difficult materials at places where rapid wetting by molten solder is required. At places where surface conditions are critical, when lead based soldiers are used, we are using the corrosive fluxes. They should be only be used on components in condition where the residues can be completely removed after soldering. The corrosive or acid fluxes consist mainly of inorganic acids and salts. They are used to solder difficult materials at places where rapid wetting by molten solder is required. At places where surface conditions are critical, when lead based solders are used, they should be only be used on components in condition where the residues can be completely removed after soldering, otherwise they may corrosive to the material. The most basic ingredient in this type of flux is zinc chloride. Corrosive fluxes having the zinc chloride. Intermediate fluxes. Intermediate fluxes are weaker in nature when compared to inorganic fluxes. These fluxes are weaker in nature when compared to inorganic fluxes. They consist of organic acids and their derivatives. These fluxes are active at soldering temperature. These fluxes are active at soldering temperature. Typical intermediate fluxes are lactic acid, glutamic acid, succinic acid, hydrohalides or amino acids. So these are the some of the intermediate fluxes. Intermediate fluxes are weaker in nature when compared to inorganic fluxes. They consist of organic acids and their derivatives. These fluxes are active at soldering temperature. Typical intermediate fluxes are lactic acid, glutamic acid, succinic acid, hydrohalides or amino acids. These are the intermediate fluxes. Non-corrosive fluxes. A non-corrosive flux is required where it is difficult to wash off flux residues after soldering. The meaning is, after soldering, if it is difficult to wash out the remaining parts, then we go for the non-corrosive fluxes. A non-corrosive flux is required when it is difficult to wash off flux residues after soldering. For electrical component, for electronic assemblies, delicate instruments, that washing is not possible. Colophony or natural rosin obtained from a particular type of fine wood contains a abatic acid and its isomers which becomes mildly active at soldering temperature, being weak acid. So that's why we use the non-corrosive fluxes. Criteria for selection of a flux. What are the criteria we are using for selecting the flux? Flow prompting properties of the flux. We need to use the what are the flow prompting properties of the flux? Solder composition. What solder we are using? That solder, depending on the solder also we will select the flux. Composition of materials to be soldered. What type of materials we are going to solder? Surrounding in which soldering has to take place. Surrounding in which soldering has to take place. Soldering technique, soldering temperature, properties of the flux residues, possible health hazards. Depending on these criteria, we will select the suitable flux for our soldering operation. Now we try to conclude that in order to get good soldering joints, wetting of solder is important. Lead is mainly used as a diluent only to lower the cost. The wetting phenomena is dependent on tin only. Solder alloys normally used are tin lead solder, tin antimony solder, tin lead silver solder. Next, solder techniques, we having that to achieve the solder joint, we having the solder necessary of the depending on the nature of the depending of the flux. So next class we are going to discuss about the soldering techniques. So we discuss about these things. During the soldering operation, an auxiliary medium is mostly used to increase the flow properties of molten solder or to improve the degree of wetting. Such a medium is called flux. So now we discuss all these in this class. Tomorrow we discuss about the different techniques of the soldering techniques. Thank you.